Let us discuss the Bohr-Rutherford diagram today. Do you know why the periodic table shows trends in properties? For example, the atomic size decreases as we move from left to right, and increases as we move from top to bottom in the periodic table. The main reason behind the trends in the properties of elements in the modern periodic table is the similarities in the arrangement of electrons. For example, let us start with alkali metal. The first element in alkali metal, lithium, we can see that the outer orbital has 1 electron in 2s orbital. Again, as we descend the group, sodium, which comes below lithium, has 1 electron in 3s orbital. Potassium, that comes below sodium, has an electron in the 4s orbital. Thus, let us go ahead and check an atom. What is inside an atom? We will learn this when we discuss the Bohr-Rutherford diagram. But before that, let us quickly revise the discovery of the subatomic particles. The electrons were first discovered by J. Thomson. He enclosed gas in a vacuum tube and applied a high voltage. A stream of particles was noticed to flow from the cathode to the anode. This beam of particles was later termed electrons. The protons were discovered by Goldstein. He observed if a perforated cathode was placed inside the discharge tube, a beam of rays in a direction opposite to that of the cathode rays passed through the holes on the cathode. These are positively charged and were termed protons. Later, Chadwick discovered neutrons. Bohr-Rutherford diagram is an atomic model, which was given by Niels Bohr and Ernest Rutherford in 1913. In Rutherford's atomic model, we saw there, the dense nucleus was concentrated at one part of the atom, and the electrons revolved around it. However, the model did not speak anything about the energy of the electrons in motion. Bohr's model of atom had inspiration from Rutherford's atomic model. In fact, we call it out as Bohr-Rutherford atomic model. Let us now go ahead and learn about Bohr-Rutherford atomic model. In this atomic model, there is a central, dense, small nucleus surrounded by electrons. An electrostatic force of attraction holds the nucleus with the electrons. The nucleus consists of protons and neutrons. Protons are positively charged, and neutrons are neutral. Thus, the overall charge on the nucleus is positive. The electrons are negatively charged, and they revolve around the nucleus in their fixed paths, called shells or energy levels or orbits. The number of protons and electrons in a neutral atom is equal. As we move away from the nucleus, the first energy shell is called the K shell, followed by the L shell, M shell, N shell, and so on. If a letter N denotes the shell number, then the number of electrons a shell can accommodate is 2n square. Thus, the K shell can accommodate a maximum of 2 electrons, L can accommodate 8, M can accommodate 18, and N can have a maximum of 32 electrons. An electron stays on its path at a particular energy. When an electron absorbs energy, it goes from an inner energy level to an outer energy level. While it returns from an outer energy level to an inner energy level, there is a release of energy. With the advent of quantum mechanics, the Bohr-Rutherford model took a back seat. However, it could successfully explain the Rydberg formula of the spectral emission lines of the hydrogen atom. For this reason, and the simplicity of the model, it is still introduced to the students in the first go. The model is also used for the explanation of many concepts. This was about the Bohr-Rutherford diagram.